Hello everybody, how are you all? Today we will talk about our lesson. What are you see in the picture? Yes, it's a moon. The moon appear at night. What happened at morning? The sun rise. What does the sun give us? Yes, it gives us light. What else can give us light? Yes, candle, the lamp. So we have two sources of light. We have natural source like the sun and artificial source like what? The lamp and candle. Good. We previously talked about the energy. What is the energy? Do you remember? The energy is the ability to do work and make change. Like what? The movement of windmill is considered energy. When you push the chair, it's considered energy. When you run, it's energy. The light from the lamp is energy. All of these energy forms. Do you think that all forms of energy can be seen? No. The light energy is the only form of energy that we can see. So it's called a visible spectrum. You can ask me, how? When I run, it's energy and I can see myself running. No, you run, but we can't see this energy. We can see you do the work, do the energy. But where is the energy? We can see it like light. We can see with our eyes. Yes. Can you tell me, is the moon considered a source of light? I will see no, it's not considered a source of light. Why? We see it luminous and lightened our night. Yes, but the moon is an oblique object. It reflects the sunlight that falls on its surface. This light reflected to our eyes, so we see it lightened. Then we will talk about the properties of light. We have 5 properties of light. We will talk about each one of them. Firstly, traveling of a light in straight lines. 2. Transmission of a light through different materials. 3. Light reflection. 4. Light refraction. 5. Light separation, splitting of light. Firstly, we will talk about the traveling of light in straight line. We will do an experiment in our lab to prove that light transmits in straight lines. As you see at the picture, place 3 partitions on straight line in front of line candle. Look at the candle light through the partition hole near you, like this. Adjust the partition's position by moving them to the right and left until you see the light of the candle through the 3 holes. What you see, you can see the light of the candle. Okay. What happened if you move a partition to the left or light, like the picture here. Do you see the light of the candle? No. Why? Because the partitions aren't in the straight lines, so the light cannot travel in straight line here. So what we can observe that the candle light can be seen when the three holes are on the same straight line with the light of the candle. That means the light travel in straight lines. Another example to prove traveling of light in straight lines, we have two phenomena that prove the light travel in straight line: the formation of images through narrow holes and formation of shadows. Firstly, the formation of images through narrow holes. We will do an experiment like we see in the picture here. Remove a side of the box, then paste a piece of semi-transparent paper instead. Bore a small hole in the side opposite to the semi-transparent paper side. Place the lighted candle in front of the hole and for a distance, then look at the semi-transparent paper. Move the candle forward and backward until you see the candle image clear on the semi-transparent paper. What you observe? The image is minimized and inverted. So, this proves that the light travels in straight lines. This experiment proved the idea of camera. How? When you take a picture by camera, the picture is inverted. But why? We see it upright, not inverted. There is a lens in the camera that moves this inverted picture to be upright and clear. So we see it clear and not inverted. The second phenomenon as a result of movement of a light in straight lines is the formation of shadow. What is the meaning of shadow? The shadow is the dark area which is formed as a result of falling light on an opaque object. What happened at morning? The sunlight fall on your surface. You are considered an opaque object. So there is a shadow formed behind you. The direction of the shadow is affected by the direction of the sun or the direction of the source of light. We will watch now a video that illustrates the formation of shadow.
On a Sunday morning, you are on your way to the market to buy some milk. The sun is shining bright on your face. You see your shadow on the ground behind you. The same day in the evening, you are out in the park playing football. The sun's rays fall on your back. You see your shadow on the ground in front of you. After a while, the sun sets. There are no more shadows. You are confused. You want to understand when shadows are formed. You are also curious to know the direction in which shadows are formed. Shadows are formed when an opaque object is placed across the path of light. Shadows can be seen only on a screen. The ground, walls of a room, building, and other such surfaces act as screens for shadows. Shadows are always formed in the direction opposite to the source of light. In the morning, since you were facing the sun, the shadow was behind you. In the evening, the sun was behind you, causing the shadow to be formed in front of you. When the sun sets, there was no light, hence there were no shadows.
We will do some exercise. Let's play with me. The first question. The energy is the ability to do what and make what? Yes, to do change and make work. To do work yes, work and make change. The sun is considered a source of what and what? Source of light, yes. And what? And heat, yes. The light is the only form that we can see, so it is called visible, yes, spectrum. Okay, check answers. Yes, all of them are true. Let's play another game. Start. At morning, when you open the curtain on windows, light enters the room. That show us to turn. What's the transmission of light? Clock. Yes. Continue. Transmission is the word we use to describe when a light ray passes through material. Correct? Another spin. Shadows made by the sun are shortest at midday. Yes. The second property of a light is the transmission of a light through different materials. Imagine we have three different materials like this picture. We have a glass material and you put it on your face. You can see your face through it because it's transparent material that allow light to pass through it. When you put a semi-transparent tissue like butter paper and place it on your face, we cannot clearly see our face like this picture because this paper acts as translucent material that can transmit some of the light and the other light is scattered and we can see clear picture. When you you put an opaque object on your face, we cannot see through it. Your face, as the opaque objects cannot transmit light through them. So the light is clearly transferred through transparent materials and transmitted through translucent material and cannot transmit through opaque materials. The third property of a light is reflection of light. What is reflection? When you look at mirror, you see your object, or when you look at clear water, like this picture, you see yourself. What happened? The light fall on the bright and smooth surface of the mirror, so the mirror act as reflector that reflect light to our eyes, so we can see our image in the mirror, the same as clear water. So we have two types of reflection. When light fall on the surface of regular or smooth surface like the mirror, the light reflected in regular direction. This is called regular reflection. But if the light rays fall on an irregular surface, like a piece of rock, the direction of rays of a light scattered, so it cannot reflect it to our eye, so we cannot see the reflection of a light. This is called irregular reflection. The fourth property of light is the refraction of light. What is refraction? When you see the pencil in a glass of water, it acts as it's broken or bent. Or why when you go fishing, you see the fish near to the surface of the sea, but actually it's far here. Why? Why this happened? Here, the light reflected from the pen on air outside the water travel in high speed. Then it travel to the surface of the water, its speed decrease. This causes bending of the pencil. The speed of light on air is faster than that in water. Like when you walk in water, like when you walk on clay? No, when you walk on clay, it's difficult. You move slowly, but in water, you move fast. Yes, this is a description of refraction. The fifth property of a light is separation of a light. What's the meaning? The light is separated? Yes. The white light, like the sunlight, can be separated into 7 colors. How? If you bring a triangular glass prism and pass a white light through it, it's separated into 7 colors. These colors called spectrum colors. We can see these colors in the sky after raining. How these colors are formed? At morning, when sun rises and it rains, what happened? These drops of rains act as triangular prism that separate the light of the sun into the 7 colors to form the rainbow. These colors are red, orange, yellow, green, blue, indigo, violet. Rainbow. We will watch a video now that illustrates the formation of rainbows.
Rainbows are one of the most beautiful sights in nature, and we usually see it on a rainy day. But you will be surprised to know that you can even see it on sunny days if you're near waterfalls or fountains. So what is really required for the rainbow to be formed? The two things that are required for the rainbow to appear are white light and tiny water droplets. The latter is quite important for its formation. In the rainy season, many water droplets are present in our atmosphere, and hence we mostly see the rainbow in this season. Okay, so how do these two combine together to form a rainbow? Well, the formation of the rainbow results from the simplest of optical phenomena known as refraction and total internal reflection. Yes, among these two, we know quite a lot about refraction of light. Okay, so let's see how sunlight and droplets interact with each other. First of all, suppose that we're looking up at a rainbow from some point on the surface of the earth. We see the colors of a rainbow in order: red, orange, yellow, green, blue, indigo, and violet from top to bottom. We might not be able to see indigo that well because our eyes are not quite sensitive to that color. Now, as I told you, rainbows during the rainy season are formed due to the presence of water droplets in the atmosphere. There are many of these where a rainbow is formed. So we are only looking at the red part of the rainbow. The simple reason that we're able to see anything around us is because the light from that particular object is traveling to our eyes. Similarly, the red light from the upper part of the rainbow is traveling to our eyes, enabling us to see it. But where is this red light coming from? In order to understand this, let's consider a single water droplet from this red region and suppose the white sunlight is incident at this point on it. The angle at which the light is incident is very important, and I will tell you why in a little while. It will reflect some of the light at the boundary and refract some of it. The reflected light is white light again, and it's going away from our eyes. So we ignore this as this light does not help in forming rainbows. But we know that the white light of sun is composed of 7 primary colors. It's VIBGYOR. And we also know that the prism will bring this white light into its constituent colors when allowed to pass through it. A water droplet behaves exactly like a prism. It disperses the white sunlight at the entry point. What happens next? This dispersed light falls onto the rear side of the droplet, and each light color is again refracted by different angles. But wait a moment. Look at this point. Why is the light getting refracted in the same medium? Well, you must have assumed that it will pass through the air and not back through the water. This is happening because of an optical phenomenon known as total internal reflection. Let me quickly enlighten you about this. We know when the light travels from an optically denser to an optically rarer medium, it bends away from the normal. And greater the angle of incidence, greater will be the angle of refraction. But here's the interesting part. There is some angle called the critical angle at which the refracted ray will be perpendicular to the normal line. That's right. At this angle of incidence, we can see that the refracted ray is perpendicular to the normal. And if I further increase the angle of incidence, then the refracted ray will now travel through the incident medium. So if you notice, the ray is actually reflecting in the same medium. The same thing happens here in a water droplet as well. This angle of incidence at this surface for each colored light is such that they all bend in the same medium. So these different colored rays are now at the air-water interface again for the third time. This time, however, the total internal reflection does not occur and they bend in air. But notice that all the colors in air are now separated by quite an amount. The three refractions create the larger gap between these colors. All the droplets in this red portion of the rainbow behave in the same way. But wait a moment. These droplets are refracting the light of all colors. Then why are we able to see only the red color in this region of the rainbow? This is because only the red color from this region reaches our eyes. All the other colors are refracted at such a large angle that they do not reach our eyes on the ground. Same thing happens for the remaining regions of a rainbow as well. For instance, droplets present in the violet region also send the light back in the same way. But only the violet color reaches us and the remaining colors are not visible. I hope that you now have a basic understanding of how a rainbow forms in the sky.
We reach the end of our lesson. I hope I meet you soon. Bye bye.